Hi everyone, my name is Andrew. I'm currently head of DevRel at Fivetran. I'm happy to be here. So, why should you listen to me? You probably shouldn't, and we'll find that out together. But just a little bit about my past before I was the dancing monkey for Fivetran. I was the dancing monkey for Tobiko, the creators of SQL Mesh and SQLglot, two open source projects that are still open source. For that, I was with Will over at Dremio. I was the field chief data officer and one of the evangelists. And then I led data at a bunch of different places, including building some of the big machine learning models at JP Morgan. I'm pointing, but JP Morgan's not actually on here. Maybe I should add it. On the side, I'm a professor. I'm a grad professor of data science at a bunch of different places. So if you want your kids to get an A, have them take my class, because I'm too busy doing stuff like this. I'm like A, 0, A. But most importantly, I just got my silver play button on YouTube. Wow. So now my wife has to introduce me as her influencer husband. So we'll see how long that lasts and if I'm still married when I get home. I just found out today that I have the most watched Apache Iceberg YouTube short in the world. Just past Dremio. Shout out Dremio. Now Dremio's going to go buy a bunch of ads on their videos. Anyway. So, I'm going to be talking a little bit about AI, you know, you're like, boo! Yeah, I get it. And AI agents and what I've seen in the field. What's actually working and what are people doing and more importantly, how does that relate to the Lakehouse and all of the work that's going on there? Because it feels a little disjointed sometimes when you think about, oh, there's a big Lakehouse movement, there's a lot of data consolidation, but also on top of that, we've got AI, we've got AI agent systems being built, and do they interact, do they not? Sometimes, we'll talk about that. I think it's helpful to talk a little bit about how did we get here, because that really has to do with the current state of things. So, I wish I had a wireless mic, but it is what it is. Yeah, bigger budgets next year. Come on now, Kennedy. So, if you think about like the data systems, and if you worked in data longer than 5 minutes, you realize that the data is fragmented, disjointed a lot of places. Now we're like, oh, let's put AI on top of that. Awesome. So how did we really get here? If you think back to like the 1950s, oh no, doesn't even work. This is good. So if you think about how we got here in the first place, you know, it'd be awesome if I could get my life together. We'd all be happier. Hold, please. We may have to just skip that. No, it's not even connected. One moment. Still on its thing. So if you think back to like the 1950s of, I might actually have to use my slides. I swear I have slides, I just hate using them. I should have checked this instead of checking my email before we got started here. Super glad this is being recorded. That's good. Yeah, it's going to be good for YouTube Shorts. That's right, this is the new one. So people are sometimes afraid of public speaking, and then you come to my talks, you're like, oh, it's actually not that hard. It's not that hard to be bad at it, for sure. Oh, it doesn't work at all. Well, that's good. We'll get back to that. We're gonna do slides for a little bit. Boo! Okay. I'm gonna watch this as soon as it pops up. We're gonna skip that. So, if you think back to, and this is the history of AI, we'll compare it a little bit. But if you think back to like AI systems and then data storage systems, their stories actually go really well together. This is made by AI, so shout out AI. But back in the 1950s, we really start getting these larger databases. And what are they? They're row-based systems, they're physical, they're hard to use. We weren't using SQL, right? And everything is very rigid. You had to hard code everything into it. So if you need to make a change, it's a big deal, it can take months. And this whole purpose is really to power applications. So it's transactional, it's OLTP, online transactional processing, just for powering applications. And if you needed to set up a new application, you set up a new physical database. So scaling was expensive and difficult. It took a lot of upfront costs. And inside these databases, the tables weren't really talking to each other. It wasn't until 1972 with E.F. Codd's paper about relational databases when inside that physical row-based database that tables really started talking together. So we start getting this idea of, oh, relational databases. But databases didn't talk to each other. You know, we were still siloed in this database supports this application. Maybe the stuff inside can talk to each other. This database supports this application. They're not going to connect. So this really continues until the 80s when IBM starts thinking about data warehouses, and then Bill Inman starts thinking about data warehouses. And that's really kind of mid-80s. They launch the data warehouse. And the whole thought behind that is, what if we've got all these isolated systems? What if there was a central repository where we could see all of this data in one spot, right? It's the source of truth, it's the dream that we're all kind of still chasing. And so Bill rolls out this data warehouse. It's still physical, it's still row-based at that time. And to get the data from these databases, we've got all these siloed databases. To support the applications, that's business critical. We can't screw up the applications. So Bill also helps create this extract, transfer, load process, the ETL process. And they don't want to script the application, so they run these long ETL processes overnight. And now that we've got all this data in one spot, well, it serves a different purpose. Now, instead of doing just writing, right, we're just writing to these databases, we're supporting applications, it's transactional. Now that we've got it in one spot, we can do this new thing called analytics. Awesome, shout out analytics. And this really is kind of kicking off in the 80s, and a lot of things happened to make this possible. So in like 1986, SQL, ANSI SQL comes out, so now it's a lot easier to interact with your data. It's really democratizing data for the first time outside of hardcore computer engineers who are dealing with the difficult databases. Now we're transforming this data and we're dropping it in schemas inside a warehouse. And now these new people called analysts can start trying to drive informed business decisions. We start getting these business intelligence systems rolling out from different companies in the 80s. But what happens? Well, you know, Bill Inman's idea of, oh, this warehouse can be a single source of truth. Well, now sales wants their single source of truth, and HR wants their single source of truth. So they have a data warehouse, and they have a data warehouse. It's like the Oprah meme of, you get a data warehouse. You get a data warehouse. And we're all kind of living with that now, where there's lots of different warehouses inside most enterprises. So in the 90s, Ralph Kimball has another thought. He's like, oh, this single source of truth thing, not working out very well. What if we do these things called data marts, where we just accept that there's really no single source of truth, and we can set up data marts which are specifically supposed to be isolated from each other, and it's the sales data mart, and that's the sales source of truth. And the HR data mart, and that's the HR source of truth. And yeah, we can have a warehouse, we can have these databases, and we're just going to be spread out all over the place, but to support the specific business unit focused analytics and business decisions, we'll just have data marts. And we see that still to this day. So if you join a new enterprise, you start cataloging the data, you're like, oh, we've got data, we've got Postgres, we've got ClickHouse, we've got Redshift, we've got all these things all over the place. Oh, we've got 7 instances of Redshift. Awesome, at least. So this is really where we're at. And everything is physical, it's generally on premises, and it's rows and columns. It's all row-based stuff. So even the data warehouses at this time are still row-based storage. So not difficult, slower to query, especially if you're doing large-scale aggregations out of a warehouse or out of a mart. And this is fine. We're doing all this structured data. Awesome. And this pen is never going to work. I think I killed it. So that's good. Robert's over here thinking like, well, at least you killed something because you're not killing this presentation. So in the 2000s, we start getting the internet, right? So now we've got this large body of unstructured data. So we were just dealing with rows and columns, and now we've got data is the new oil. Collect all the data. We've got all this unstructured data. And around that time, we also started getting data lakes, right? So Hadoop rolls out. I think it becomes an Apache project in like 2006. We get Amazon S3 around that same time, 2006, 2007, so we can start moving stuff into the cloud. Now all of a sudden the ability for us to scale up doesn't necessarily require us building all of these machines and all of this storage. We can just rent space on Jeff Bezos' computer. And so the cost, the upfront infrastructure costs, enable us to start putting everything in the cloud. We're like, oh, storage is cheap now, right? That's what you think until you leave your instances on or somebody leaves, and you know, we've all been there, and you have that fun talk with your CTO. So now we start putting stuff in the cloud, and this is also when we can start doing columnar storage, right? Columnar data types. And columnar is much faster for analytical large queries for aggregation. So we're still doing row-based on databases, perfect, transactional. Now we've got OLAP, online analytical processing in our warehouses. We start moving stuff into the cloud. We start getting Snowflake. We start getting Redshift. And in our data lakes, we start storing all this unstructured data. But there's no schemas. We're just kind of throwing it in there. We're not tracking it. Governance is a nightmare. There's no ACID transactions on a data lake, right? So you delete a column, and maybe it's deleted, maybe it's not, maybe it shows up on a board report later. That was fun. So we're storing all this stuff, but we're not using it, really. And when I took over, I was leading data at a large institution, and so one of the first things I did when I joined was I started cataloging, like, what are all like our most used data sources across the landscape. And one giant table that I found was just this transactional table sitting in our data lake, sitting in S3, that just had millions of transactions every day. I was like, what is this thing? Like, oh, it's the key card swipe for all the people. Every door they go in and out, they have to swipe the key card. And there were 50,000 people at the main campus, and then 80,000 total. And so you can imagine the number of key card swipes. I'm like, oh, okay. So why do we have this? And they're like, oh, it's valuable. I'm like, oh, okay. What are we using it for? They're like, nothing. I'm like, oh, good. So that's kind of the mindset of how we were using data lakes. It's like, we're storing all this stuff because we can and because we think it's valuable, and we never use it. Especially data lakes, because it was hard. So, you know, the people really using data lakes were machine learning engineers, right? Because you can do deep learning on top of object storage, on top of raw files. You know, Will has his PhD. I'm sure he'll come up and give us a lecture on how to do that. But the deep learning were really the only ones in the data teams that I've led that were really using the data lake. You're not telling your analysts, like, hey, go do analytics on those JSON files. They're not doing it, right? They're going to Snowflake. They're going to their data warehouse. But now we've got this giant sprawl of data systems. We still have our transactional databases. We need those. They're fast, they're secure, solid ACID transactions. We're ETLing all that stuff into a warehouse so that then our analysts can actually use it in a bunch of different warehouses, if we're being honest. And then we've got this data lake out there that's just collecting all of this unstructured data, because we're like, oh, data's the new oil. Like, yeah, you're right. It's hard to get to, and it's difficult to use unless you refine it. So this keeps going just like this until 2015, 2016, when Delta Lake and Apache Iceberg and Apache Hootie all come out about the same time. So what's the purpose of that? So Apache Iceberg rolls out of Netflix, where they are trying to use all the data in their object storage, but they're having the issues of lack of consistency. There's no ACID transactions on the data lake, and so they've got this big data sprawl. They think, what if we could consolidate data in the data lake, but have the characteristics of our data warehouse? If we could have schema evolution, if we could have partitions, if we could have ACID transactions and compliance, if we could actually like govern it and control who has access to the data lake. Wouldn't that be awesome? And so that's these open table formats. That's their whole purpose, is to add data warehouse-like capabilities on top of your object storage. And so this has existed for 10 plus years, but it's only been recently where folks are actually starting to explore it. And I think that's a common theme with enterprises adopting open source technology. When I started leading data teams, we weren't even using R or even Python a lot of times because we're like, oh, it's open source, it's not secure, especially in financial services. We had to use SAS because we're like, oh, SAS is guaranteed. Now it's open, and I think it's pretty rare to find SAS only shops these days. So similar, I would think, with adopting open table formats of let's see if it's productionizable, let's see some other use cases. Often it's big tech who's going to adopt these first. And so 10 years, 5 minutes, this is Francesca saying, shut up, everyone's bored, I get it. So I remember, 2 years ago, I helped start the San Francisco and the Seattle Iceberg meetups, and I had to beg people to come. Everybody's like, boo, we don't want to come, talk about Postgres. But yeah, nobody came except like the people who worked at Snowflake, and they had to come because it was at their office. So now the most recent San Francisco Iceberg meetup had hundreds of people. They had to get special approval from Apache to have like 400 people go. And now the Iceberg Summit's coming, and we expect 700 in-person people and thousands of online attendees. And this is because the open table format works. We see it at production. We see Lakehouse is working. It helps consolidate a lot of our data sprawl. But how does this relate to AI? So when I helped build machine learning systems at JP Morgan, and we were just doing Google BERT. And we were doing natural language processing and trying to identify like what's a red flag and what's not. And it was really hard to consolidate this data, so you ended up creating just specialized, you missed the best talk. Man, you might as well just go home, it's all downhill from here. So it was really hard, so we were like, oh, let's set up a new Redshift instance, and like this will be, it's kind of that data mart mentality of like, oh, this one warehouse will support this big ML initiative. And now with AI, it's not, because we're trying to generalize the use cases, that's not really feasible in setting up a new data storage strategy for every single AI instance. So now with generative AI models, it benefits from more data, more high quality data, but more data. And so if you're trying to connect it to Postgres and MySQL and SQL Server and all this crappy data in our S3 and our Snowflake and our Databricks, because they both told you they could do AI, and they can, but it is what it is. So they're also partners, so we're not saying bad things about them. So, but we've got this data sprawl. You'd be surprised at the number of enterprises that have Snowflake and Databricks, and different teams are using them. So what if you could consolidate that data in a lakehouse and still have all those governance controls where not everybody can see everything? Oh, actually I have slides on all this, but it doesn't matter. They're all made by AI anyway. But this is what I'm seeing is the path to consolidation so that we can have AI on top of it. Because what do you need? If you're doing deep learning, you need raw data. Awesome. That works on just plain Jane data lakes. If you need to do machine learning or analytics, you need that next step up. You need that normalized data where it's cleaned, it's deduplicated, it's accessible, it's governed. Awesome. We can run tree-based, we can run regression, all of that. And that's really where we've been. But now we've got generative AI. What does that need? It needs contextual data. Uh-oh. Well, context means more and higher quality. So if you can have that on your data lake where you can consolidate it, you can control the storage and compute, and you can have your generative AI running on top of that, awesome. But now we've got a next level up, agents. Now agents needs more operational data. It needs to understand the context windows, it needs to know your policies, what should it remember, what should it not remember, for how long. Well, this really benefits from transactional data. So we go back to the Postgres, the ClickHouses, the Altinities, and it really can benefit from streaming data. If you have an agent who's trying to manage inventory control or fulfilling orders, it needs to be streaming a lot of times. So what does that look like? In practice, what I'm seeing is folks are consolidating a lot of their OLAP, their analytical processing, into lakehouses because you can control storage and compute. You can have different engines based on the use case, right? DuckDB for small things, Spark for big things. Dremio for everything else, I don't know, Trino, and then you can have things like ClickHouse to help manage your, and Altinity to manage your, yeah, shout out Altinity, to manage your transactional processing, and there's awesome ways that they can combine that. And so this is what I'm seeing, is a lot of data consolidation, but increasing the quality and the quantity for AI. And you get that a lot through these open table formats like Apache Iceberg, but it doesn't necessarily replace everything, it just helps consolidate the sprawl. Now instead of 40 warehouses, what if we could just use the object storage that we've been storing for years, but have governance and controls and organization on top of that? And that's when you're gonna see widespread enterprise adoption of AI. Awesome. I have a demo, so come see me afterwards. I know I'm out of time, but I've got a demo that shows ingesting Parquet, turning it into Iceberg, putting a Polaris Rust catalog on top of it, and then having an AI agent do text and hybrid vector search on top of it. So it's showing it in practice. So feel free to see me afterwards. Awesome. Thank you so much. Does anybody have questions? Because I am seeing these systems pop up in real time, and I think one disconnect is generative AI versus agentic AI, because they have very different data needs. One really is operational, and the agent is sitting on top of either your analytics or a LLM. It's not, an agent is not an LLM, for instance. Please.
So on the one side, we have prognosis that we make.
Oh man.
So now I get the microphone.
That's right.
So on the one side, we have the machine learning models that make prognosis based on historical data, which of course, the more we feed it, the more accurate it gets, unless something out of the ordinary happens. And on the other side, we could use autonomous AI to just monitor streaming data, as you mentioned before, and that could react to sudden changes much quicker or recognize new patterns much quicker. And I mean, I don't know if that's the right question for this, but this just popped up. How would you combine those two in order to gain maximum reaction time?
So it depends. There's a few different things, right? So the question is, fast acting versus, like, what's the latency and how to combine those when they have different strengths? It really depends on your use case. So you really don't want to throw generative AI at everything or agents at everything. You need to work backwards and think, what's the specific business outcome I'm driving? What's the strongest capability, and also the simplest a lot of times, to meet that objective? And then what's the data that's needed to meet that capability to reach that business outcome, working backwards. So a lot of times it should just be an ML model, right? Yeah, I mean, if you're doing clustering, you don't need an LLM to do clustering a lot. You don't need it to do segmentation. You can just do it and then have that activated or reverse ETL'd back into Salesforce or whatever it is. You don't need an LLM to do that. You could have an agent sit on top of that, and you can just interact with it using natural language, but it's going to be pulling from that historical data. So understanding what's the latency need to reach that business outcome is important. The other aspect is thinking, where should the human be in the loop? And that's different organization by organization. If you're doing agentic analytics, right, putting an agent on top of your analytics stack, how should it be able, where's the human in the loop? Is the loop seeing just a citation? Is the human seeing maybe a SQL query, or how is that working? Because it's the difference between deterministic and probabilistic functions. So SQL, deterministic, right? Vectors, probabilistic. And should you be using probabilistic functions to answer a deterministic question of what was my gross revenue last month? That should probably just be a SQL query that an agent could do, versus pulling unstructured data from VectorDB and trying to probabilistically give you an output that it thinks it should be. So getting an agent that can do a router, using OpenRouter, using LangGraph, so that it has access to both systems, and can make the decision. Should I run a SQL query? Should I hit the vector DB? Yeah. So I know that's a long-winded question, or long-winded answer, probably didn't answer the question, but I think we're seeing more combinations using technologies like LangGraph. So you can do a router approach where it has access to lots of these different approaches, and it can pull from either or all of them, combine it, and return it. And then the observability, having the stack tracing, having citations, that'll depend on the use case and the sensitivity of it.
Right, thanks for this architecture input.
Yeah, of course.
Okay. Questions?
Awesome. Thank you.
Okay, so now we have